and welcome to my YouTube channel. Each episode I'm going to cover a physics topic and hopefully try and explain it in a simple and understandable way. Some episodes are just going to be fun physics facts, but most I'm going to try and tie in to the current school curriculum. So when that's the case, I'm going to put the key stage in the episode title. Today's episode, I'm going to explain to you the very fun, the very exciting Hooke's Law. So Hooke's Law can help understand the laws of elasticity, torsion and force in a spring. Ooh, springs! The basics of Hooke's Law is that the extension of a spring is proportional to the force applied to it. So to start with, you need to know the equation F equals minus kx, where F is the force applied to the spring, x is the displacement of the spring, basically how much the spring stretched by, and k, which is the spring constant, and this is just a characteristic of every spring that tells you either how stiff or flexible it is. Let me explain why there's a minus sign in there. Basically, the spring's force is always going to be in the opposite direction to the force applied to the spring. So if you attach a heavy weight or an object to a spring, it will pull it downwards and stretch it, whereas the actual spring's force will always be trying to pull it back in the opposite direction to its equilibrium. Hence, when you release the force or the weight applied to the spring will bounce back into its original shape, provided that the force applied wasn't too large. Anyways, so you have F equals minus kx. But when you're working out the magnitudes of the spring constant or the displacement, you don't need to worry about the minus sign. Huh? The minus sign is there to demonstrate which direction the force is being applied in. So only use the minus sign when you're working out the force. Okay. The K, so the spring constant, is a characteristic of the spring, so it can't be changed unless you change which spring you have. And as long as you have two of the values from this equation, you can always work out the third. So let's give you a super easy example. Woo! So when you apply some mass to a spring, this is converted to a force by multiplying it by 9.81 meters per second squared, as that's the gravitational pull on Earth. So if you apply 1 kilogram of mass to a spring, you will be applying 9.81 newtons of force to the spring. Simples! Go on then, let's try work out a spring's K value. Let's say we already know we want to stretch the spring by 10 centimeters, so 0.1 meters. Then we apply a mass of, let's say, 1 kilogram. So we've applied a force of 9.81 newtons. We rearrange the equation to get K equals F over X. So we have 9.81 divided by 0.1. So this spring has a spring constant of 98.1 newtons per meter. Let's do it again! I am just loving this. Let's say we already know the spring constant. It's been given to us by the manufacturer or whatever. So we know the spring constant is 98.1 newtons per meter. And we can't be bothered to set up the experiment, but we do want to know how much the spring would stretch by if we applied 1 kilogram to it. We get this mass in terms of force by multiplying it by 9.81, which gives us 9.81 newtons. Quick maths. So now we have X, which is the displacement, equals force divided by the spring constant. So we have 9.81 divided by 98.1, which gives us the displacement is 0.1 meters. And finally, let's say we already know the spring constant and we already know we want to stretch the spring by 20 centimeters. Let's work out how much force we need to apply. So you have F equals minus kx, so you multiply 98.1 newtons per meter by 0.2 meters, which means that we applied 19.62 newtons of force. What's that in mass? Well, to work out what mass we then need to apply, we divide 19.62 by 9.81, which gives us the mass applied was 2 kilograms. What that lovely example has shown us is that the force is directly proportional to the displacement. Did you notice? In my first two examples, we were working with 1 kilogram of mass and a 0.1 meter displacement. As soon as I doubled the displacement value to 0.2 meters, the mass also doubled to 2 kilograms. This happens because the spring constant is just that. It is a constant. So, no matter what force is applied, the displacement will always be proportional to it. And vice versa. So, if you halve the force applied, the displacement of the spring will also halve. Or if you want to stretch the spring by 10 times the amount, you need to apply 10 times the force. Apply the force, Luke. It is all very clever, but simple and fun as well. Thank you for listening! I hope you liked this video, and if you did and you want to learn about other cool physics facts, then please like and subscribe and watch all of my other videos. And if you want to learn about a specific topic, please leave a comment below and I will try to do a video for you.